Welcome to Maths for All. I'm Aisling Flynn. This is Higher Level. This is Statistics, Confidence Intervals for a Mean. Point estimates. Because populations are often very big, we often have no way of knowing exact parameters, for example, the mean of the population or the standard deviation of the population. And for that reason, samples are used. Samples can give a single value to estimate a population parameter, and this is called a point estimate. However, we must give some indication of how good this estimate is, i.e., its accuracy. How accurate is it? How likely is it to be true? To do this, we construct a confidence interval. So an interval gives a starting point and a finish point, a from and a to, and confidence means how sure or how certain are we of what we say. In our course, we construct a 95% confidence interval. This means that if we constructed this interval 100 times by taking samples, the population parameter, so the true value, is expected to lie within the interval 95 times out of 100. Okay, margin of error. The margin of error E for the population mean. Now I must stress that in this lesson we are talking only about confidence intervals for the mean of a population. Okay, so we're focusing on means. So the margin of error for the population mean at 95% confidence level is given by, okay, E equals 1.96. all right, we'll talk about that value in a little while, and you'll recognize sigma over root n as the standard deviation of a sample, okay, where sigma is the population standard deviation and n is the sample size. However, we rarely know the population standard deviation, so we use the standard deviation of the sample as an approximation. So if you don't know sigma for the population, you can use the value for the sample. So let's create a confidence interval. The 95% confidence interval for the population mean mu is here. Okay, so let's go through this, where x bar is the sample mean. So in the center here you see mu, which is the population mean, or the true value if one was to calculate every single piece of data from the population. Okay, and so the confidence interval begins with the sample mean minus the error. So the error you see here is 1.96 times the standard deviation of the sample, and it goes up to that same sample mean plus the error, and you see the error here, okay, where x bar is the sample mean. So what is this value of 1.96? Well, it comes from our 95% confidence level. Okay, so when we learned the empirical rule, we learned that 95% of the time the value is within 2 standard deviations from the mean. Okay, and that was somewhat simplified. It's actually 1.96. okay, so this is a z-score, okay, 1.96, and here's its opposite on the other side, minus 1.96. so 95% of the time the value will land in this proportion. Okay, so that's where 1.96 comes from. Okay, is there anything to help you in the formula and tables books? Well, not a lot. What you do have is the standard error of the mean here on page 34. You can see the sigma over root n here. What it does not give you is the 1.96 for the 95% confidence level, so you do have to recall that yourselves. Okay, here's an example. A survey was carried out to estimate the weekly rental costs of holiday apartments in a certain country. A random sample of 400 apartments was taken. The mean of the sample was €400 and the standard deviation was €50. Form a 95% confidence interval for the mean weekly rental costs of apartments in this country. So as soon as you see 95% confidence interval, you're talking about a from and a to an interval, and we need margins of errors to go with that. So what I do first is I write down my information from the question. The sample is 400 apartments, so n equals 400. The mean is €400 and the standard deviation of the samples is 50. Okay, we're going to have to calculate an error, margin of error for that, and what we use, we've just learned, is 1.96 by sigma over root n. Okay, now in this case we haven't been given the population standard deviation sigma, so we're told we can use the sample standard deviation if we have it. Okay, so when you substitute into that, so we put 50 over root 400, what we get is an error of 4.9. Okay, and now we can construct our confidence interval, so it will be the sample mean minus the error and the sample mean plus the error, and the true population mean should lie 95% of the time between these two values. Okay, so we'll have €400 minus 4.9 and €400 plus 4.9, and that will give me an interval of €395.10 up to €404.90.